All right, so I just wanted to finish with looking at an example and talking about the expected value and the variance. So this is just continuing to talk about binomial distributions. And so this is something that is pretty relevant to students. Let's say that you have a 25 question multiple choice test with 5 options. And let's just say you are just going to guess. You're just going to send it throughout. Just guess on everything and see what comes out. So we could figure out the probability of you getting 1 right or 20 right or 25 right by using a binomial distribution. So, because we can think of this as a binomial distribution with 25 questions and a 1/5 chance of being right. So, for example, the probability that you get a perfect score would look like this. It would be 25, choose 25 times 1/5 to the 25 times 4/5 to the 0. You're going to get 1/5, so let me just see real quick. I'm curious what 1/5 raised to the 25th power is. So that comes out to be 3.355 e to the negative 18, so times 10 to the negative 18. So remember, that means you slide that decimal 18 times over. That's just not going to happen. That's very unlikely. But we can still talk about the expected value here. So the expected value of x, if you watch the last video, I showed, you know, uh, just a sketch of the proof. I didn't write all the details, but a sketch of how you show what the expected value is. For a binomial distribution, the expected value is just n times p. So all we got to do is 25 times 1/5, which means that you're going to, on average, you'd get about 5 questions, right? With that, we could figure out maybe a more interesting question. What's the probability that you do better than average? So what's the probability that x is greater than 5? Well, that would be a pain in the butt to do directly because we'd have to do the probability that x is 6 and 7 and 8 and 9 all the way up to 25. Or you can use your calculator to do it, or you can do 1 minus the probability of getting 0, 1, 2, 3, or 5. So here I'll show how to do it. If you look right above the word vars here, you've got the distribution. You hit the second button of the distribution button. And if you scroll down until you see where it says binom. The PDF means a specific point, and the CDF means cumulative, so a range of values. So I'm going to do CDF here for x is greater than 5. So that's option A. And then here, let's see, I think we type in the number of trials, the probability, and then the lower bound 6 and the upper bound at 25. Let's see. Maybe I do it backwards. Some of the calculators have different interfaces, so I just want to figure out what way pops out an answer. Let's try one other thing. Let's see. 6 to 25. Huh. That's weird. Here, let me pause for a second and consult my good friend Google. I see. So on this calculator, the way it wants you to type it in is using the binomial CDF, and you type in your N, your P, and your C, and this is going to tell you the probability that X is less than C. So it goes from the bottom up to C. So the way that we do this for being greater than 5 is we go 1 minus the probability here of binomial distribution. So 1 minus the binomial CDF of 25 trials, probability of 1/5, and we're going to go from 5 on down because I wanted to know what's the probability to do better than average. So let's try to type that in. Okay, so 1 minus, I hit the second button and I hit the vars button to bring up binomial distribution. It's down option A, 25, comma 1/5, comma 5. There we go. That comes out. See how I typed it in there? And so what this means is that, you know, about 38% of the time, you're going to do better than average on it. If you wanted to know the probability that you would do worse than average, you can just type in the binomial distribution 25, comma 1/5, comma 5, and that would be the inverse right there. Oops, I see I just made a mistake that this should have been 6 right here because of how it says X is less than 6. So let me fix that. Apologies about that. It changes our probability down to 21.66%. So anyway, the idea there is that the binomial CDF will count up from no successes up to the C value you ask about, tell you the probability of that happening. Last thing I wanted to show you with this example is the variance of X is NP times 1 minus P. So 25 times 1/5 times 4/5, which ends up being 4. And that tells you, the bigger the variance, that tells you the more spread out your probabilities are. So if you have a big variance, that means that you are expecting values that are very far from the expected value. If you have a small variance, your values are going to be very clustered around there. 4 is not an especially big variance. You're probably more familiar with the standard deviation. The standard deviation is the square root of the variance. So if I wanted to take the standard deviation, that would be 2. And if you think back to your normal distribution, about 2/3, 68%, are within one standard deviation. So about 68% of the time, if you guessed on a test, you would be within 2 points of getting 5. So about 68% of the time, you'd get between 3 questions right and 7 questions right. So sorry about having to mess around with the calculator a little bit, but please ask for help here and let me know if there's anything that was confusing.